This slide introduces the key topic of our course: Blackhat Acqua security and S3 vulnerabilities, specifically focusing on the bucket monopoly attack in 2024. Our goal is to provide a comprehensive understanding of these vulnerabilities and how they manifest within AWS services. We'll explore the mechanics behind the bucket monopoly attack and examine its implications for S3 security. By the end of this course, you should be well equipped to identify and mitigate such vulnerabilities to protect your AWS infrastructure effectively. In this course, we will comprehend the intricacies of S3 vulnerabilities and the specific dynamics of the bucket monopoly attack within AWS services. As your instructor from SecuriTech, my objective is to guide you through the characteristics and potential impacts of such vulnerabilities, paving the way for effective mitigation strategies. In this course, we are going to cover several essential topics. We'll start with an introduction to Amazon S3 and shadow resources to lay a foundational understanding. Then, we'll move on to exploring various vulnerabilities within AWS services. A significant portion of this course will be dedicated to understanding the bucket monopoly attack, a newly identified threat in the cloud security landscape. Finally, we'll discuss effective mitigation strategies to protect against these vulnerabilities. This comprehensive approach aims to equip you with the knowledge necessary to safeguard your AWS environment against potential threats. Understanding the importance of this topic is fundamental. The relevance is clear. Mastering these concepts is essential for cloud security professionals. By thoroughly understanding the vulnerabilities in AWS services, you'll be better equipped to prevent account takeovers and data exfiltration. This knowledge forms the backbone of robust cloud security practices. Shadow resources in AWS, such as automatically generated S3 buckets, play a significant role in your cloud environment. These resources are not created explicitly by the user, but are instead automatically generated by AWS services to support various operations. For example, when you use CloudFormation, Glue, or EMR, AWS automatically creates S3 buckets for storing templates or logging data, among other things. These are known as shadow resources because they operate behind the scenes to facilitate service functionality. Understanding shadow resources is essential for effective cloud security management, as these resources can also become vectors for potential security risks if not properly monitored and configured. Let's focus on some key characteristics of AWS S3 buckets. One important aspect is global uniqueness. S3 bucket names must be unique across all AWS accounts, not just within your own account. This means that the bucket name you choose should not conflict with any bucket name in use anywhere in the AWS ecosystem. Moving on to naming conventions, examples in names such as CF templates hash region and AWS Glue assets account ID region. These naming patterns help in managing and identifying buckets by embedding pertinent identifiers like regions and account IDs. This structured approach aids in avoiding naming conflicts and maintaining organization when dealing with multiple buckets across various AWS services. In this slide, we focus on the vulnerabilities present in various AWS services. It's important to highlight that these vulnerabilities can impact several critical services within the AWS ecosystem. For instance, CloudFormation, Glue, EMR, SageMaker, Service Catalog, and CodeStar are all susceptible to potential threats. Understanding these affected services is fundamental to developing robust security measures. We will look into specific examples and workflows of such vulnerabilities, starting with CloudFormation in the next section. By scrutinizing these weak points, you can better safeguard your AWS environment against common exploits. Here, we'll examine the vulnerability associated with AWS CloudFormation. When a user creates a new stack, CloudFormation generates an S3 bucket to store templates. The naming pattern for these buckets follows the format CF-templates hash region. This predictability poses several problems. First, it makes the bucket names predictable, which introduces a security risk. An attacker could potentially create a denial of service attack or inject malicious code by exploiting this predictability. Specifically, if an attacker preemptively creates an S3 bucket with the predictable name in a region not used by the victim's service could unknowingly write templates to this bucket, leading to potential data breaches or unauthorized code execution. This demonstrates the importance of unpredictable naming patterns for security essentials. On this slide, we'll focus on exploiting the CloudFormation vulnerability through resource squatting. This technique involves an attacker creating an S3 bucket using the predictable naming pattern we discussed earlier. Here are the steps for resource squatting. 1. First, the attacker creates an S3 bucket with a predictable name in a region not used by the victim. 2. Then, when the victim's service attempts to write templates, it unwittingly writes them to the attacker's bucket. 3. As a result, the attacker gains access to sensitive data or can inject malicious code. For executing this attack, the attacker would use commands like shell AWS S3 mbs3 /cf templates # EUS-2 AWS S3 API put bucket policy bucket cf templates # EUS-2 policy files bucket policy.json. These actions enable the attacker to establish control over the bucket, intercepting and manipulating the data flow to gain unauthorized access or to introduce security threats. Now let's focus on vulnerabilities related to Glue, EMR, and SageMaker services. Each of these services uses specific naming patterns for their S3 buckets, making them susceptible to similar types of attacks we've previously discussed. For Glue, buckets are typically named using this format: AWS Glue Assets Account ID Region. EMR follows a pattern like AMStat Studio Account ID Region. SageMaker uses SageMaker Region Account ID. By exploiting these naming conventions, attackers can perform actions such as remote code execution, RCE, data manipulation, and data exfiltration. Essentially, if an attacker is able to hijack these names and set up their own buckets, they can intercept sensitive data or even inject malicious code into the victim's environment. Understanding these vulnerabilities is essential for designing a secure infrastructure and preventing unauthorized access. On this slide, we're discussing the bucket monopoly technique. This method leverages predictable naming patterns to exploit vulnerabilities. Here's how it works. 1. First, identify predictable bucket naming conventions used by services like Glue, EMR, and SageMaker. Examples include names like AWS Glue Assets Account ID Region for Glue. 2. Next, create buckets in all regions where the victim has not yet claimed these names. Then, configure these buckets to be publicly accessible and apply permissive policies to them. 4. Finally, the attacker waits for the victim to use the service in a region where the attacker has control over the bucket. This technique targets the lack of unique naming and insufficient security policies, leading to potential risks such as remote code execution, data manipulation, and data exfiltration. In this real-world scenario, we're examining a case study of an S3 bucket squatting attack. In this situation, an attacker managed to gain control of a Glue bucket. By doing so, they were able to modify Glue job scripts and execute arbitrary code. This highlights major security lapses, specifically in bucket policy and naming conventions. By exploiting insufficient bucket policy security and failing to implement unique bucket names, the attacker found an opening to compromise the system. This case underlines the importance of stringent bucket policies and the need for unique and secure naming conventions to mitigate such risks. In this slide, we will focus on the commands and tools essential for detecting and preventing S3 bucket squatting. Specifically, we'll look at examples using AWS CLI. To check the ownership of a bucket, you can use the following command: AWS S3 API head bucket -bucket cf templates #EUS-2. This command will help you confirm if you own a particular bucket by returning the bucket's metadata information. Next, if you need to set a bucket policy, you can use AWS S3 API put bucket policy AWS Glue Assets Account ID -EUS-2 policy file /bucket policy.json. This command applies a policy from a file to the specified bucket, ensuring you maintain the intended access controls and security measures. These tools and commands are pivotal in maintaining the security and integrity of your S3 buckets by making sure ownership and policies are as intended. Now, let's talk about mitigation strategies. It's important to implement best practices to secure your S3 buckets effectively. First, always use the AWS resource account condition in your bucket policies. This helps ensure that only resources from specific AWS accounts can interact with your buckets. Second, always verify bucket ownership before using them. This adds an extra layer of security by ensuring you're interacting with the intended resources. Finally, use unique, non-predictable names for your buckets. This minimizes the chances of unauthorized access. Names that are too generic or follow predictable patterns can be more vulnerable to attacks. Implementing these strategies will significantly enhance the security of your S3 resources. In conclusion, S3 bucket vulnerabilities present a significant risk to your data security. By adhering to best practices, such as implementing the AS resource account condition in bucket policies and verifying bucket ownership before use, you can mitigate these risks effectively. Additionally, assigning unique, non-predictable names to your buckets further secures your resources. As your next steps, thoroughly review AWS security best practices and maintain continuous monitoring to ensure ongoing protection of your assets. Moving on to references, we have two key resources to help you reinforce the concepts covered. First, the Acqua security blog article, Bucket Monopoly: Breaching AWS Accounts Through Shadow Resources, provides insightful examples and scenarios of how S3 bucket vulnerabilities can be exploited. Second, the AWS documentation on S3 bucket policies offers detailed guidelines on securely managing your S3 buckets, ensuring you understand the correct configurations and policies needed to protect your data effectively. These references are invaluable for deepening your understanding and applying best practices to your AWS setup.